And we back. We're talking about some organic chemistry here. What the heck is that? Does it cost more at the grocery store? Is that what that means? This is the main topic for today. We're going to break it up into 5 lectures. They should all be pretty short though. So we talked about, kind of intro to the course. We talked about different levels we're going to be talking about. Scientific method, chemistry, special properties of water. We're building our way up to a cell and then to tissues, and then we're going to get into organs and organ systems. So organic chemistry, what the heck is this? What is an organic, this is kind of what we're going to go over today in this little lecture. What is an organic molecule? So there's a couple different words for these. So we have organic molecules. Organic molecules. Another word for this is macro molecules. And last but not least, biomolecules. Molecules. And these are actually one word each. Molecules. Macromolecules. And some of us may have heard this one, right? Macromolecules. Get your macros. This is like a fitness diet term. Like, what's your macro content? How many lipids, protein, carbs are you getting? All right, so organic molecules, macromolecules, biomolecules. We can just think about these being interchangeable for this course. What does it really mean? Well, organic, we've talked a little bit about this. It just means it's made out of carbon. Made out of carbon. That's essentially what organic means. It's made out of carbon. Macromolecules for this case just means large. That's what macro means. Instead of micro, it's macro. Like a Mack truck. Macromolecules. Large molecules. Large misspelled word. Molecules. And biomolecules, bio means life. So these are life molecules. Alright? Those are the kind of like more specific definitions. And the main macromolecules, there's 4 of them, and I briefly mentioned them. We have sugar, or carbohydrate. This is your carbs. We got lipids. We'll draw lipids in green, I guess. Lipids. The specific type of lipid is a fat. Then we've got protein. And last but not least, we got nucleic acid. We don't really think about that one in our diet, but it is there. And this is, of course, like DNA. And protein, this guy here, these are the tiny machines of your cells. That's what a protein is. It's a tiny machine of your cell. And so by the end of this, kind of the promise that you'll get, some of the promises of this topic. It's pretty cool. Like, I love this stuff. I could think about this stuff all the time. It's like, you'll understand better. You will understand better your food. What is that stuff that I'm eating? Like nutrition labels will make sense. I don't have a ton of time to go into all that, but like you'll get a pretty good understanding of like this is the main stuff that you're looking for, is your carbs, lipids, and protein. So something you might be better at cooking now. You can just think of cooking as playing with macromolecules. It's really all it is. It's playing in a laboratory. using chemistry. And you'll better understand the chemistry that you are made of. Pretty cool stuff, pretty cool topics, if you ask me. And kind of one major cool thing that we'll kind of debunk and explore just a smidge is like, people often think that protein is meat. Or like the only source of protein is meat. And we're just we're gonna decimate this and show how wrong this is. Just how absolutely incorrect it is to think that way. Because all cells have protein. Okay, so let's just kind of dig into organic molecules on a very kind of broad scale here. Let's check into my list here. How are we doing? Overview of organic molecules, types of organic molecules. Look at that. We're already crushing this. Look at this. Okay, so differences between inorganic and organic. All right, well, we already got one little list here. Let's just make two. Let's just make two little lists. We'll make inorganic, and we will make organic. We'll do that in blue. Organic green, because life is green. Plants are at least green. All right, so what are some properties here? So this will have like ions often. So like salt, charged atoms. Ionic bonding is often present. Ionic bonding is often present, obviously. Small number of atoms. And associated with non-living matter. These are just some simple ways to kind of think about this. And organic, we can just get right down to it. It almost always contains carbon and hydrogen. Just like I said here, it's made out of carbon. It's covalent bonding. Contains covalent bonding. Large. Says it right here, large molecules, not a small number of atoms, and it's associated with living things. Right? We would have to also define what these mean. What are non-living things versus living things? We'll save that for another day. All right, so carbon, we know a little bit about it. How do we actually represent this stuff? So we can have, let's say we got a molecule here, and it's 8 carbons. So it's going to be 1 carbon, 2, 3, 4, 5, 6, 7, 8. We're not going to draw the valence shells and all that stuff. We'll just draw like a little connector here because they're bound to each other. Like so. And then each one of these carbons, if you remember, carbon can bind to 4 different things if it's single bound on each of them. So then each one of these carbons is also going to have hydrogens coming off of it. Like so. Boom, boom, boom. And you'll get this all in organic chemistry, again, if you take that. So each one of these would have a hydrogen coming off of it. Like so. It's cumbersome, but we'll talk about a better solution once we go through this process. All right, so this would be a octane. This is a hydrocarbon. This is a hydro, because it's got hydrogen and carbon. It's a hydrocarbon. And there's lots of different types of hydrocarbons. This is specifically, has 8 carbons, so this is specifically octane. You get high octane gasoline. You want this in there. It's gonna, be good for your fuel, for the burnings. A lot of energy in this. All right, so that's one way we can draw it out. It's pretty cumbersome. Well, another way we draw this out is kind of like a skeleton form. So this is rather cumbersome to draw out. So there is a simpler way to draw it out, and that's by doing this. And I'll actually use this little tool here, this little line tool. So we can draw out a hydrocarbon like this too. This is not perfect, but let's see, 1, 2, 3, 4, 5, 6, 7, 8. So this would be the same thing, and you just draw the little backbone of the carbon like this, and each one of these vertices represents a carbon. So each one of these represents a carbon. That represents a carbon, that represents a carbon, that represents a carbon. Each vertex represents a carbon. This is just a faster way to draw it out. So we can draw out molecules like that. Molecules can be in the shape of rings. So for example, we can draw a 6-sided ring here. Let's do that. Draw it in black. Don't want these arrows. Like so. Beautiful. Okay. This would be a carbon ring. This would be cyclo. It's like a cycle. Cyclohexane. It's got 6 carbons. Cyclohexane. You don't necessarily care that you know the names of these, but I'm just giving you an idea of them. And it's kind of assumed, we don't draw them in, but we know that also there's going to be the hydrogens coming off of here. There'd be hydrogens coming off of all of these, but we don't draw them in. Just give you guys that little taste of how we draw this stuff. And I'm just going to give you a couple things, and then we'll wrap it up here. I want to give you this little thing because I think it's kind of cool. So hydrocarbons can come in all different sizes and shapes and lengths and all this stuff, and they're very useful. And hydrocarbons come from this substance called crude oil, like for example, in your car. And we can get all kinds of stuff from that, from crude oil, which is really old plants from millions of years ago. We dig up oil, and it's made out of all different kinds of hydrocarbons of all different lengths, and that's what these are here. So then we take this crude oil and we boil it up, just like water. And if it's real heavy, the real heavy stuff will come out here, and the real light stuff will come out up here, right? It'll boil off quickly, go up to the top, come out up here. So our 80 carbon stuff's going to come down here. Our gasoline's 8 carbons, high octane gasoline. Kerosene's 12, for example. Lubricating oil's pretty large. It's got 36 carbons coming off of there, so we draw a carbon chain 36 carbons long. Naphtha, which is lighter fluid, also 8. And gas, natural gas coming off with some 4 carbons and stuff there. So like, just to give you a little idea of, not all of this stuff is, like, this is old life that is now hydrocarbons that we dig up and we burn it. So this is also like useful like in your home. Like I have a gas stove right now. That thing's using gas, which is a hydrocarbon. So it's probably some 4 carbon or 1 carbon, potentially 2 carbon, it's some carbon gas, and we're burning that. And one last little thing is like the way we draw these out. I'll give you a little picture here. I'll give you 2. The way we actually draw these out is actually how they look, which is kind of crazy to think about. So we can use a microscope. That's essentially like a record player. It's got a very thin needle on it. So a record player has a very tiny little needle, and it sits in these grooves of vinyl, which is a hydrocarbon. And it vibrates. That little needle vibrates. It feels that groove, and then we can translate that, amplify that sound into a louder sound through a speaker, And that's how we hear music. And then our inner ear cilia, little hair cells, start to wiggle. And then our little myosin motors start to wiggle. And then now we're dancing because our muscles are wet. Anyway, let me get back to the point here, is this little tiny needle feels this groove, and then we feel the groove. Well, we can use a microscope that has such a thin, if we zoomed way on this, the microscope that I'm talking about would like have the thinnest little needle that's the size of one single atom. And it's one single atom thickness. It's so sharp that it can then feel around the edges of atoms. It's called atomic force microscopy. And we can actually look at organic molecules with this. And so here we have a large organic molecule drawn out, like we would draw it out with our skeleton system that I just did here. It's just the same thing, just more complicated. You know, we got a little carbon skeleton here, carbon rings here, and this atomic force record player microscope went through and felt this, and this is the image that it pulled up. And you can see that it looks like that. That's actually what it looks like. This molecule here actually looks like this. So on and so forth. They actually look like this. It's pretty freaking cool. You know, some of these are not as clear to see. It's a little harder to see this perfect little line here because we got these hydrogens in the way sticking off of it. But when we draw out molecules like this, that's actually what they look like. Can't see them, but we can feel them. It's kind of nifty. Okay, we'll continue it on. We're going to talk about sugars and carbohydrates in the first one, but that's just a little brief overview into organic molecules, macromolecules, or biomolecules. And I'm going to check these off because, guys, I freaking crushed it. I did it. All right. See you in the next one.